For over a century, the accepted rule was simple. Humans didn't reach the Americas until roughly 13,000 years ago. Every textbook said it. Every museum exhibit reinforced it. Generations of archaeologists built their careers defending it, but on a crumbling, forgotten island in the Chesapeake Bay, a geologist has spent over a decade collecting nearly 300 artifacts that suggest something far more radical. That people were standing on this land while most of North America was still buried under ice more than 22,000 years ago, and the island holding this evidence is disappearing faster than scientists can study it. The island is called Parsons Island. It sits quietly in the Chesapeake Bay, off the coast of Maryland, near Kent Island. 78 acres of marsh, sand, and low bluffs, privately owned, rarely visited, and slowly being erased by the water around it. To most people who have ever seen it from a boat, it looks like nothing special. Just another patch of green and brown clinging to the edge of a bay that has been swallowing islands for generations. But to one man, this island is not disappearing. It is confessing. His name is Darrin Lowery, and his relationship with the Chesapeake shoreline did not begin in a laboratory or a university lecture hall. It began when he was 9 years old, walking along the beach near his home on Tilghman Island, just southwest of Parsons Island. It was 1977. He was a child doing what children do near water, kicking through sand, picking up rocks, looking for anything interesting enough to take home. And on that ordinary afternoon, he found something that was not ordinary at all. A stone point fluted along its base, shaped with a kind of deliberate precision that even a 9-year-old could sense was not natural. It looked like the kind of tool associated with the Clovis culture the group long believed to represent the very first Americans. At the time, nobody thought much of a boy finding an old stone on a beach. Arrowheads and points turn up along the Chesapeake all the time, but that single object did something to young Darrin Lowery that would not fade. It planted a question in him that never really left. Who made this? When did they stand? Here. What was this place like when human hands last touched this stone? He did not know it yet, but that afternoon on the beach set him on a path that would eventually place him at the center of one of the most contentious debates in American archaeology. A debate about who actually got here first and how badly we may have miscalculated the timeline. Lowery grew up, and that curiosity did not fade the way childhood fascinations often do. Instead, it hardened into a vocation. He became a geologist, trained to read the layers of the earth the way most people read a book, from the bottom up, oldest to newest, each stratum a sentence in a story written over thousands of years. And it was that geological training, more than anything else, that would eventually make his work on Parsons Island so difficult to dismiss. Because here is the thing about the debate over the first Americans. It is not really an argument about arrowheads. It is an argument about dirt, about sediment, about the razor-thin difference between an artifact resting on top of a layer that formed 20,000 years ago and an artifact that has slipped down into that layer more recently through some disturbance in the ground. Critics of early arrival dates almost always attack the context, not the object itself. They ask whether the tool could have moved, whether burrowing animals, tree roots, or flowing water shifted it downward over time, making something recent look impossibly old. This is where most pre-Clovis claims have died. Not because the artifacts themselves were fake, but because scientists could not agree that the surrounding soil told an honest story. Lowery understood this better than almost anyone, because his early career took him deep into exactly this kind of forensic soil work. In 2010, he published research in the journal Quaternary Science Reviews describing layers of windblown silt, a fine dust called loess, deposited at a place called Miles Point in Maryland. According to his analysis, these layers had built up gradually between roughly 13,000 and 41,000 years ago. But there was a problem. Within those layers, he found what geologists call an unconformity, a gap, a missing chapter. Somewhere in that sequence, thousands of years of sediment history simply were not there, erased or never deposited, leaving a hole in the timeline exactly where the most important evidence should have been. Most researchers might have logged that gap as a frustrating dead end and moved on. Lowery did not. He kept looking along the shoreline, kept walking the eroding banks the way he had as a boy, and eventually he noticed something unusual. A dark streak running through the sediment, visible where the bay had chewed into the land. A band of stained, organic-rich soil that seemed to be leaking out of the crumbling edge of a nearby island. That streak was coming from Parsons Island. He believed, based on his experience reading these bluffs, that this streak might be exactly what was missing from Miles Point. A continuous, undisturbed record that could fill in the years that had gone unaccounted for. But there was an obstacle. Parsons Island was privately owned, home to a single family who valued their privacy and had no particular interest in strangers digging around their land. That family was the Corcorans, and to his credit, Lowery did not sneak onto the island or attempt to work around them. He asked, he explained what he was looking for and why it mattered, and eventually the Corcoran family granted him permission to study the eroding shoreline of their island. What followed was not a quick dig with a triumphant discovery on day one. It was years of patient, repetitive, almost obsessive work. Lowery began making regular trips out to Parsons Island, motoring across the bay in his boat, walking the base of the bluffs where the water had carved fresh exposures into the land. Every visit, the shoreline looked slightly different than the last because every visit, a little more of the island had fallen into the bay. This was not incidental to his research. It was, in a strange way, the engine driving it. Because Parsons Island is eroding so rapidly thanks to rising sea levels and the relentless wave action of the Chesapeake, new layers of ancient sediment are constantly being exposed. Layers that would otherwise remain buried and inaccessible for centuries are being peeled open by the water itself, offering researchers a narrow, temporary window into deep time. Over the course of roughly a decade, working with a shifting cast of collaborators, students, and fellow researchers, Lowery began pulling artifacts directly out of these exposed layers, not from the surface, not from disturbed soil that had been plowed or built upon, but from intact sediment sequences that could be dated using careful scientific methods. Stone flakes, cutting tools, fragments that showed clear signs of deliberate shaping by human hands, not the random fracturing that happens naturally when rock breaks apart on its own. Piece by piece, trip by trip, the collection grew. Eventually, the total reached 286 cataloged artifacts recovered from the southwestern edge of the island, the section taking the worst battering from the bay's currents and storms. 286 separate pieces of evidence, each one collected with careful attention to exactly which layer of sediment it came from, because in this line of work, the layer is just as important as the object itself. And then there was the oldest piece, a specimen recovered in close association with charcoal, the burned remnant of ancient fire, embedded in the same sediment layer. Charcoal is valuable to archaeologists because it can be radiocarbon dated with a level of precision that stone alone cannot offer. When that charcoal was tested, the results were staggering. More than 22,000 years old. Sit with that number for a moment. 22,000 years ago was not some vaguely distant era in a general sense of old. It was the depth of the last glacial maximum, the coldest point of the most recent ice age. During this period, enormous ice sheets, some over a mile thick, stretched across huge portions of what is now Canada and the northern United States. Sea levels were dramatically lower than today, because so much of the planet's water was locked up in glacial ice instead of flowing through oceans. The landscape of North America would have looked almost unrecognizable, a frozen, wind-scoured world utterly different from the temperate bay region we know now. If Lowery's dating is accurate, it means that while glaciers a mile deep were grinding across the northern half of the continent, human beings were already present far to the south, along what would eventually become the shores of the Chesapeake Bay. Not arriving. Already there. Already living, working stone, moving through a landscape that mainstream archaeology long insisted was empty of people. To understand why this claim ignites such strong reactions, you need to understand the story that came before it, the story that Parsons Island is challenging. For most of the 20th century, the dominant model in American archaeology was known as Clovis first. The theory held that the earliest humans in the Americas arrived across the Bering Land Bridge from Siberia sometime around 13,000 years ago, moving south through an ice-free corridor once glacial conditions eased, and eventually developing a distinctive style of fluted stone spear point that archaeologists named Clovis, after a site in New Mexico where these tools were first identified in the 1930s. Clovis, points were found scattered across the continent in remarkable numbers. And for decades, the presence of these tools was treated as essentially synonymous with the first human presence in the Americas. If you found evidence of humans, and it fit within that time window and it looked like Clovis technology, it fit comfortably into the accepted story. If you found something older, something that did not match the pattern, you had a serious problem, because you were now arguing against consensus, and consensus in archaeology, like in most sciences, does not yield easily. For decades, that resistance was not simply academic caution. It shaped careers. Researchers who claimed evidence of pre-Clovis habitation, meaning human presence before the 13,000 year mark, often found their work dismissed, their methods scrutinized far more aggressively than research that confirmed the existing timeline, their reputations sometimes damaged in ways that took years to repair. Some archaeologists coined a phrase for this pattern of institutional resistance. They called it the Clovis police. Researcher after researcher who tried to present pre-Clovis evidence found themselves facing what felt less like scientific skepticism and more like a kind of gatekeeping and instinctive rejection that seemed to exist regardless of how strong the evidence actually was. Over time, however, cracks began forming in the Clovis first model, and eventually those cracks became too large to ignore. Sites like Monteverde in Chile, meticulously excavated and dated by archaeologist Tom Dillahay, produced strong evidence of human occupation roughly 14,500 years ago. predating Clovis and located thousands of miles south of the traditional entry point into the continent. After years of fierce debate, Monteverde eventually gained broad acceptance, forcing the field to grudgingly push the accepted timeline backward. Other sites followed, each one chipping away a little more at the old model. Meadowcroft Rock Shelter in Pennsylvania, excavated by archaeologist James Adovasio beginning in the 1970s, produced dates suggesting occupation as far back as 16,000 years. That claim faced intense criticism from the start and remains heavily debated even now, with some researchers still questioning whether contamination from older carbon sources in the surrounding coal-rich geology may have skewed the dates. Still, taken together with other emerging sites, the pressure on Clovis first kept building. By the time Lowery began seriously publishing his findings from Parsons Island, the scientific community had already shifted considerably from where it stood decades earlier. The rough consensus among most archaeologists today is that humans were present in the Americas at least 15,000 years ago, and quite possibly earlier. That number itself represents a significant retreat from the old 13,000-year Clovis first boundary, achieved only through decades of grinding, often bitter, scientific argument. Parsons Island does not simply nudge that number a little further back. It proposes to smash through it entirely, suggesting a human presence roughly 7,000 years earlier than what is broadly accepted, and doing so not at some remote fringe of the continent, but in the mid-Atlantic region, along a bay that millions of people drive past every single day without a second thought. This is precisely why the claim has generated both excitement and serious pushback in equal measure. Because pushing the timeline back by a few thousand years is one thing, skeptical, but within the range of plausible ongoing revision. Pushing it back by 7,000 years, placing humans in Maryland during the absolute coldest depths of the last ice age, is another thing entirely. It does not just adjust the existing story, it demands an entirely different one. It suggests waves of migration into the Americas that occurred far earlier and by routes that remain poorly understood, whether along ice-free coastal corridors, by boat following the Pacific coastline south, or through pathways that current models have not even fully considered yet. So, how does the scientific community actually respond to a claim like this? Not with simple acceptance, and importantly, not with simple dismissal either. Serious researchers examine dating methods, examine stratigraphy, examine whether the artifacts show unambiguous signs of intentional human manufacture rather than natural fracturing that can sometimes mimic stone tools in misleading ways. This scrutiny is not some hostile conspiracy against inconvenient evidence. It is how the discipline is supposed to function, and frankly, it is how it must function, because archaeology has been burned before by claims that seemed compelling at first and later collapsed under closer examination. James Feathers, a specialist in a dating technique called optically stimulated luminescence, worked directly with samples from Parsons Island before retiring from the University of Washington. Optically stimulated luminescence, often abbreviated as OSL, is a method used to determine how long ago a mineral grain, like a grain of quartz sand, was last exposed to sunlight. When sediment gets buried, it stops receiving light exposure, and radiation from the surrounding environment gradually builds up a measurable signal within the mineral's crystal structure over time. By carefully measuring that accumulated signal in a controlled laboratory setting, researchers can estimate how long the sediment has been buried, functioning as a kind of geological stopwatch that started ticking the moment the sand was last covered. This technique matters enormously for a site like Parsons Island because it does not depend on the presence of organic material like charcoal. It can date the sediment itself, providing an independent line of evidence that either supports or contradicts the radiocarbon results. When both methods point towards similar conclusions, confidence in the dating increases substantially. When they diverge, it raises red flags that demand further investigation. Feathers offered an observation about the culture of archaeology itself that is worth pausing on. He remarked that, to a certain degree, old ideas and old prejudices in a scientific field do not always die through argument alone. Sometimes, he said, you have to wait for people to die off. It is a blunt, almost uncomfortable thing for a scientist to say publicly, but it reflects something real about how scientific consensus can function. Researchers who built entire careers defending a particular model are rarely eager to abandon it, even when new evidence accumulates. Sometimes, genuine paradigm shifts require not just better data, but an entirely new generation of scientists who did not have their professional identities built around the older framework, and who are therefore more willing to look at controversial evidence with fresh, less defensive eyes. This is part of what makes Lowery's persistence so significant. He has continued this work for well over a decade, not despite the controversy, but seemingly undeterred by it, motoring back out to Parsons Island trip after trip, watching the same bluffs he has studied for years erode a little further with each visit, salvaging what he can before the bay claims it for good. He has described the eroding sites along the Chesapeake using a particular word, persnickety, a word that captures something true about this kind of research. These sites are difficult, fussy, demanding, requiring painstaking attention to detail and constant vigilance, but Lowery insists that difficulty should not discourage interest in them. If anything, he argues, it should spur far more of it, not less. He has used a striking comparison to make his point about urgency. He has noted that if a colony of silverfish, the small insects known for consuming paper and documents, were discovered actively chewing through irreplaceable materials inside the National Archives, there would be an immediate, energetic public and institutional response. People would mobilize. Resources would be found. Nobody would shrug and let priceless historical documents be destroyed simply because acting on it required effort and urgency. Yet Parsons Island, an unrepeatable archive of deep human history written directly into the earth itself, is disappearing into the Chesapeake Bay largely outside of public awareness, with only a small handful of dedicated researchers working against a ticking tidal clock to save what can still be recovered. That clock is not a metaphor. It is a literal physical countdown playing out in real time. Rising sea levels, driven by broader climate patterns, are accelerating erosion throughout the Chesapeake Bay region generally, and low-lying marshy islands like Parsons Island sit directly on the front line of that process. Every storm that rolls through, every unusually high tide, every winter of a harsh wave action chips away more of the island's edge. This is precisely the same slow-motion process that has already fully claimed other Chesapeake islands within relatively recent memory. Holland Island, once home to a thriving waterman community with dozens of residents and even its own school, gradually lost so much land to erosion and subsidence that the last standing house on the island collapsed into the bay in the year 2010. What was once inhabited, functioning land is now largely gone, swallowed by rising water and a slowly sinking landmass. Parsons Island faces a strikingly similar trajectory. Only this time, the stakes involve not a 19th and 20th century fishing community, but potentially the earliest chapter of the entire human story on this continent. Every year that passes without full, thorough excavation of Parsons Island represents artifacts and sediment layers being lost forever, washed away into the bay before they can ever be properly studied, cataloged, or dated. There is no do-over available here. There is no going back to recover material once the bay has claimed it and dispersed it across the bottom of the Chesapeake. This urgency inevitably raises an important, uncomfortable question. If the evidence genuinely points toward a dramatically older human presence in the Americas, why has this not already triggered a massive, urgent, well-funded excavation effort? Why is this critical work still resting so heavily on the sustained dedication of one geologist and a small shifting circle of collaborators, rather than commanding the kind of large-scale institutional response you might expect for a discovery with this magnitude of implication? Part of the answer circles back to that persistent skepticism surrounding pre-Clovis claims generally. Archaeology has, in all fact, been burned before by evidence that initially seemed convincing and later fell apart under closer, more rigorous scrutiny. Sites once championed as definitive proof of very early human presence in the Americas have sometimes been quietly walked back or reinterpreted entirely. Once dating methods improved or additional analysis was conducted by independent researchers. That accumulated history of false starts and retracted claims has understandably made much of the field cautious, and in some corners genuinely resistant when it comes to embracing new pre-Clovis evidence, even when that evidence is presented by a credentialed, experienced geologist with a demonstrated, methodical track record. There is also the simple matter of funding. Archaeological research is expensive, requiring laboratory time, fieldwork logistics, equipment, and dedicated personnel, and funding bodies naturally favor projects that align comfortably with the existing consensus. A site openly challenging that consensus faces a steeper path towards securing the resources needed for large-scale excavation, even when the preliminary evidence is compelling. And then there's the nature of the site itself. Parsons Island is privately owned. Access depends on the continued goodwill of the family who owns the land, not on any formalized, publicly funded arrangement. The island is actively eroding, meaning any large-scale excavation would essentially be racing against the same forces that first expose the artifacts. It resists the kind of slow, methodical, multi-year excavation approach traditional archaeology typically depends upon. Despite these obstacles, Lowery has continued the work regardless, methodically building his case one documented trip at a time. His approach leans heavily on the geological context surrounding each artifact, not the artifacts alone. He emphasizes understanding precisely how each stone tool relates to the sediment layer it came from, whether that layer shows undisturbed continuity, and whether radiocarbon analysis and optically stimulated luminescence testing actually agree with one another. This distinction often gets lost in casual coverage of pre-Clovis claims. It is not about finding an old-looking rock and declaring it ancient based on appearance. It is about reconstructing, layer by layer, an entire geological history of a place, then situating each artifact within that timeline. Lowery's training as a geologist, rather than as a traditionally trained archaeologist working from the surface downward, has shaped his distinctive approach. He reads a bluff first, as a geological sequence, and only secondarily as a source of artifacts. That sequencing is precisely what lends his claims a level of credibility that some other pre-Clovis sites have sometimes lacked. None of this, it must be said clearly, means the debate is fully settled, or that Lowery's specific conclusions have been universally accepted throughout the broader archaeological community. Genuine, substantive scientific disagreement continues, and it likely will continue for quite some time yet, possibly years, possibly longer. Some researchers remain unconvinced that the deepest, oldest layers at Parsons Island are as undisturbed and continuous as Lowery's analysis suggests they are. Others raise more specific technical questions about whether certain recovered stone fragments genuinely show clear evidence of deliberate, purposeful human manufacture, or whether at least some of them could plausibly be the product of entirely natural processes, such as repeated freeze and thaw cycles fracturing rock for very long periods of time, or simple mechanical wave action along the shoreline breaking stone apart in ways that can sometimes superficially mimic the appearance of intentional human tool-making. These are not trivial objections raised in bad faith. They represent exactly the kind of rigorous scrutiny any extraordinary scientific claim should have to withstand before it becomes broadly accepted. And to his credit, Lowery has never framed his work as final, triumphant proof that single-handedly overturns the established timeline. Instead, he frames it as compelling evidence that deserves serious, sustained attention and further investigation, while acknowledging plainly that not every question surrounding it has been fully answered yet. What makes Parsons Island so genuinely fascinating, beyond the scientific stakes, is the poetic irony sitting at the center of the story. The same process actively destroying this island, the erosion driven by rising seas and severe storms, is simultaneously the very thing making this discovery possible. Without that ongoing erosion, these sediment layers would likely remain buried indefinitely, hidden beneath the surface for who knows how many more centuries. It took the island's destruction to reveal what may have been waiting underground for over 20,000 years. Lowery seems to understand this irony better than almost anyone studying the site. He has described his work on these disappearing Chesapeake sites as something approaching a personal swan song, a final chapter to a career that began on a different beach nearby, back when he was just a curious 9-year-old boy who picked up a strange fluted stone that nobody else thought twice about. There is something quietly compelling about that arc. A single childhood discovery leading, across decades of curiosity and methodical work, to a serious challenge against one of the most entrenched theories in American archaeology. Whether Parsons Island ultimately succeeds in rewriting the established timeline of the first Americans, or instead becomes another contested, unresolved case study cited as a cautionary tale about the difficulty of proving very early human presence beyond reasonable doubt, remains to be seen. Additional research is clearly still needed. Independent dating, ideally conducted by outside laboratories, unaffiliated with Lowery's own team, would help either strengthen or responsibly challenge the conclusions drawn from the site. Further peer review, deeper scrutiny of the sediment layers, and possibly the discovery of corroborating evidence at other nearby sites would all help settle this question, whichever direction the answer eventually leads. What is certain, with no ambiguity, is that the window for gathering further evidence from Parsons Island is steadily closing with every passing year. The Bay does not wait for scientific consensus to form before continuing its slow, relentless work. Every winter storm claims another section of that crumbling bluff. Every year, without a truly comprehensive, well-funded excavation effort, represents irreplaceable information being permanently lost to the water, scattered across the floor of the Chesapeake Bay, gone before anyone gets the chance to properly study it. So the island keeps eroding, quietly, indifferent to the scientific debate swirling around it. And Darrin Lowery keeps returning to it, trip after trip, boots planted in the shallow water at the base of that same crumbling bluff, patiently reading the layered story the Earth has been writing there for well over 20,000 years. Whether or not the wider world at large ever fully comes to accept what he genuinely believes he has found out there, one thing remains completely certain regardless of how the broader debate eventually resolves itself. Somewhere, out in the middle of the Chesapeake Bay, a small forgotten island is disappearing, and as it does, it is quietly, steadily forcing us all to ask a fundamental, deeply uncomfortable question that we thought had already been settled decades ago. What if we have simply had the story of the first Americans wrong this entire time?